data mining, knowledge discovery, machine learning, algorithms, methods, examples. All these are different terms, or this is a word cloud where you can just relate to machine learning, like data mining, knowledge discovery, statistical learning, pattern recognition, computational learning, and predictive analytics. So these are in a way related to machine learning terms. So just now, let's see machine learning by example. Some of you might have already know what machine learning is can do for us. But one particular example of machine learning is classification. We, just all of us here in this training use emails. If it wasn't through email, we wouldn't have communicated. So when we use email, a spam filter is one of the capabilities that most email service providers provide to us. And in those spam filters, nobody is sitting there and just checking whether or not an email that's sent to you is either just a legitimate email or a spam email. So computer gets trained on historical data on such inputs as email subject, email body, the length of the message, the sender email domain, and the number of recipients. Based on these criteria, machine learning, just a machine can be trained to have a model, a machine learning model that we call a spam filter. Now, here, what you see at the center is a model that we call a spam filter, just checking each of the emails and then classifying them as either non-spam or spam. So this is just one particular example of machine learning, which is classification. As you can see, the input is here, the email subject, email body, the links, the sender email domain, and the number of recipients. This we could have like thousands of records about such details, thousands of email metadata, just having these values. And then using this data, we train a computer, use a classification algorithm, and generate an output. That generated output will be a classification model. And when we use the classification model on emails, we would get it spam versus not spam output. Then just we take the next action. So the program will take the next action that you would need to be done on a particular object. Next, so another classification is from data to discrete classes. As you can see here, this is a weather prediction. In a weather prediction, usually you would get number, right? Numbers. Those numbers would be whether or not the temperature is higher, whether or not like there is a certain drop of rain, whether or not there is rain, or depending upon different climatic metrics, you can generate numbers. And combining those numbers, you will say, oh, okay, today or on this day it's going to sunny, or it's going to be cloudy, or it's going to be rainy. And you can even associate a certain number, the numbers that you predicted for these specific scenarios. Or there could be like snows, or depending upon the number. But the input would be the quantitative data about the current state of the atmosphere or the land and ocean, and using technology to project how the atmosphere will change at a given place. Is there a question? Zacharias?
So another example is a regression model for predicting a numerical value, and such model can be used in stock market. And the input would be historical price movements, market signals, mergers, acquisitions, financial earning reports, and etc. This is the most common data sought in the stock market. Is there any? We capture different types of market signals. right? How much is being sold? How much is being how much is the sale, right? Another example is clustering, which is grouping similar things together. And just this is one of the algorithms, the unsupervised algorithms that group uh, uh, similar objects together. So you can see like the colors are the groupings, right? You have these colors that distinguish between different groups. And let's say just the input data is life expectancy at birth and the gross income mortality under 5 years and expected use of schooling, etc. Using this input data, we could create a cluster of three groups, and these three groups can be seen as developed, developing, underdeveloped. So these are like how we could classify countries based on the details that we see here, and say so these are countries which can be grouped together. We don't. We simply we use data and then based on that data, we group countries. We create a clustering um, uh, model that groups countries. And another is embedding and dimensionality reduction. Sometimes the data that we see may be very difficult to see, understand, to grasp by simply looking at it, especially when it becomes multi-dimensional, more than a three-dimensional data set. When that is the case, then we may convert the data to a lower dimension, such as converting words into vectors or converting images to vectors so that we can see the dimension in a reduced dimension. Words, thousands of words could be converted to vectors, and how like just images with multiple colors could be converted to vectors, or multiple channels could be converted to vectors. And the input could be a high dimensional data in document or image or video, etc. Then once it is reduced, the output would be simple data with few attributes without losing the original context of it. So here we have like words converted to vectors. Here we have image converted to vectors. In any case, for visualizing the data, we convert a high dimensional data into a low dimensional data, most of the time like just in a 2 dimension or a 3 dimension. And we will see some examples in this area. And there are different applications of machine learning in science, environment, retail, for in manufacturing, in security, marketing, management, finance, and web. Just to mention, for example, in relation to application to our country, Ethiopia, we could use machine learning models trained for intelligent fraud detection for in our financial institutions. Most recently, we have seen people tampering with financial transactions of individuals, and then especially like just employees. And we could create models that track similar kind of activities and identify who is doing what and in what kind of pattern. And the fraud detection is an important approach to protect the financial well-being of industries, companies, and also individuals. Because to gain trust from customers, financial institutions should build such capabilities of protecting the people. So that's one particular example. And just we can apply security related machine learning models. And in this case, fraud detection or anomaly detection is one of the popular applications in different scenarios. And in case of marketing, for example, clustering is another good example here. for promotion. You can group different customers into different types of a company's customers can be grouped into different clusters or can be grouped into identified clusters so that one you can provide a specified service for those groups similar customers or do discount for those customers that are not frequently coming in buying items from you. Credit scoring and risk analysis are also again other applications of machine learning. And even in healthcare, machine learning application is important. Before the worst thing happens to a patient, you can have a model to predict about just based on different information on the patient, then just a machine learning model can predict going to happen. But the model has to be trained on a similar scenario across multiple using data from multiple patients over the years. Now the overview of machine learning. This is like just one of the cheat sheets of machine learning and dividing machine learning. So we will see a deeper dive of each of the machine learning approach. So, today machine learning. There are three types of machine learning. One is supervised, the other is supervised, and the third one is reinforcement learning. And each of these models have got their own application. For example, in unsupervised learning, we say that there is a dimensionality reduction, which means reducing the dimension of data to a lower dimension without losing the context. This application, this kind of models can be applied on big data visualization, on meaningful comparison, and structure discovery, and feature elicitation or feature extraction. The other unsupervised learning approach is clustering. And clustering can be applied for recommender systems, such as like when you search on a shopping site, you will see, oh, you can buy this, and then also people who bought these also bought these other items. So this kind of recommendations improve sales for a particular site. So this is a recommendation. Or you may be searching for books and you may not have enough insight about just the type of book that you're searching for. If you don't know the specific item that you want to buy, recommender systems will tell you, oh, you're looking for this book. But people who search for this book also bought this book. So this is the kind of recommendation that you can have. So models that are trained for recommendations are used in recommender systems. In targeted marketing, which we mentioned earlier, clustering. And customer segmentation, also segmenting customer either for providing some discounts or sending an email to encourage them buying what they used to buy. So depending upon your target, you can segment customers for different purposes. So clustering has got these different applications, and you see the other applications in case of classification, identifying fraud, image classification, or customer retention. So these are the way that you would classify your customers. That you would use classification models for diagnostics. And in case of supervised learning, just other types of the other supervised learning is regression. Regression is mostly used for forecasting and for prediction, depending upon the type of environment, type of domain that you're planning to use the technology. You can utilize any of these machine learning models. In any case, to summarize this slide, we have three types of machine learning approach: the unsupervised learning, the supervised learning, and the reinforcement learning. But what is unsupervised learning, what is supervised learning, and what is reinforcement learning. We will learn more about that in detail in subsequent weeks. And the different types of algorithms that we saw, we will see how we can build, how we can create machine learning models that would do most of the things that we said machine learning, whether unsupervised or supervised machine learning, would do for us. The objective of machine learning is, using the cheapest and abundant data and generating the most expensive resource, which is knowledge. So that's what the ultimate objective. This is the pyramid of wisdom. So the ultimate objective of machine learning is ensuring that data can be, although cheap, can be used to extract insights, useful insights, and finally just enable or add additional additional intelligence to applications and services that we use in one or more scenarios. So this is the ultimate objective. So when is machine learning used? That's it. So this is a question that we would need to answer. Machine learning is not going to be always used. There are scenarios where machine learning can be used, and there are scenarios machine learning cannot be used. Among the scenarios where machine learning can be used are situations where human expertise doesn't exist. For example, you cannot send people to navigate Mars, so you would have to use robots to do navigation on Mars. So you will need this kind of intelligence. So that intelligence can be trained using data, and you can create artificial intelligence based robots, and the underlying model is a machine learning model that drives the mechanics of the robots. And when humans are unable to explain their expertise, for example, in speech recognition and in vision, it's very difficult to, because this is the most complex area. And then just in that case, you would use machine learning models. And for example, solutions need to be adapted or customized to particular cases for biometrics, for personalized recommendations. I mentioned this during our last, my in first class, which I'm repeating again. Personalized recommendations, you can say you can recommend people, even your friends. But if you have so many thousands of people coming into your shop, which is impossible. So when I say shop, not a physical shop, but just a website, like just an online shop, it's very difficult to provide recommendation for everyone. Just humanly difficult, humanly impossible. So what you should be doing is training models and watching what these people are trying to window shop, and then based on their window shopping, you encourage or you provide them recommendation. So the people's ability, you cannot utilize people, but you can utilize machine learning models to provide personalized recommendations. And models are based on huge amounts of data. And in case of genomics, it's because of machine learning that the heads in the healthcare or in the field of medicine, like most things are getting just revealed now. There are so many breakthroughs in the most recent years because of the advent of computer and also just the advent of machine learning. So these are where machine learning can be used. But where is when is machine learning is not needed, right? We have to stop trying to trying to create models for everything, because when simpler alternatives are already exist that are equally effective, you shouldn't have to, because you wanted to use, you shouldn't use a machine learning model, right? Because you can create a machine learning model, you shouldn't create. You have to see whether or not there is an alternative solution, or a simpler alternative solution. Because machine learning model, creating a machine learning model has got its own cost. Maintaining the model has got cost. But if you have a simpler alternative that you can use, avoid the use of machine learning model. And when the relationship between all system variables is completely understood. So usually machine learning model is very effective when things are complex, especially when you are not able to explain. For example, vision, speech recognition, right? Or classification of image, when you have to do like thousands of attributes to be understood, and then just make classifying a particular image with those many attributes to a certain type. So when that's the case, you use machine learning model. But when you have everything well understood, simple, then just you shouldn't use a machine learning model. Uh, and the other one is if interpretability of results is not possible. Most of the time, like just unsupervised machine learning approach suffer from explainability and interpretability. So we shouldn't always have to just utilize machine learning models if we cannot properly interpret how we created the models, how we could use the models. And if there is a high error susceptibility, or if the model is a very poor performing model, there is no reason of using a machine learning model in that scenario. If you have a very limited training data and the variance of the model, and is so worse with the model is overfitting or learning more about the training data, not about properly predicting on testing data. That's a very good indication that you shouldn't be using a model, or you have to rethink about just what you're doing. So machine learning is incredibly powerful and can have significant or unintended negative consequences on society through targeting, excluding, and misusing. When this is the scenario, stop using machine learning. Stop using machine learning. Mainly, like the last point, has been an important issue, and there are even laws that are being discussed to create responsible AI, or responsible ML, responsible machine learning, or responsible artificial intelligence. Responsible AI is an area which is being well studied, well researched, because there are situations where people were being excluded, or people were being targeted. A very simple example, at times when your accent is like mine, the model doesn't understand what I'm talking about. And then when the text gets generated, the text may just, from my speech, when a text gets generated, the generated text may send a wrong message to the fluent speakers of English, or if we train a model for Amharic or Afan Oromo or any other language in Ethiopia, and some non-native speaker is using that model, and then just we are generating corresponding text, we may end up generating a message that would be inappropriate to the culture, to the people, or to the fluent speakers of that particular language. And if that's the case, you shouldn't have to do or enable the model to do that. If that's if it creates a negative or if it has a negative consequence on particular society or community, right? So one particular example is, no, I'm not understanding kind of uh, uh, people of different races, right? People of different color, and not only in different scenarios, and people economically uh, like people with low economic standing, right? So these kind of scenarios could happen, and if that's the case, if you realize that that's going to be the situation, you should avoid or watch your machine learning model. Now, this is the most common process or framework that has been underused for the last 20 years, even more than that. And it's called a cross industry standard process for data mining. And this is the most commonly used process or framework for machine learning practices. And the first thing, before trying to create a model or searching for data, is understanding what business are you trying to use that model in, what kind of problem you have. Understanding the problem, understanding the business is the first thing that you should be doing. And next, you try to identify whether or not you have the right data and for whatever machine learning process or data science process that you are after. And in this case, once you identify the data sources, you have to understand the data and also prepare the data. And then you choose one or more algorithms, and then using the data, you can train a model or multiple versions of a model, and you evaluate. So this is an iterative process. During your evaluation, your model may suck, may not do what you wanted it to do, or you may have difficulty of answering the problem, the business problem that you identify during your business understanding. And if that's the case, you have to refine the business problem and also just identify the right data source and understand the data. So this is a kind of iterative process. Between evaluation and business understanding, you may have this. And even when you try to understand the data that you will be using for training a model, you may not understand, or you may not get the right data to answer the right business problem. So this is a required iteration. And one thing from my personal experience at Microsoft, people assume that here, people assume that we have like data scientists can understand each and everything. That's not the true. And the other thinking is, every software engineering process is identical, right? So that is something that you should be very careful. Trying to fit a totally different process into a process that you already know. Machine learning, machine learning process in practice is completely different and has got this kind of framework that you need to apply. Asking more questions is not a sign of weakness. Asking more questions is not a sign of not understanding, but just a sign of willingness to understand or to properly understand the problem. And doing things in an iterative way, especially, for example, between preparing data and training a model, is a way of refining your trained model to make the model a well-performing model so that it addresses the business problem that you define at the beginning. And once you identify the model that you are satisfied with, and then just you evaluate according to the matrix that you created during the business understanding. And once you are satisfied with the evaluation process, and then the machine learning model addresses or answers the business problem with the expected performance matrix defined during business understanding, then just you go and deploy the model. So this is how it goes. Although there is no line between deployment and business understanding, I noticed a glitch. Although there is no line between deployment and business understanding, at times you may have to start a new process. But after deploying your model, you would have to also refine the process, because a deployed model might need to be refined. A model that was trained and deployed 6 months 6 months ago may not perform well after 6 months or after a year. So just this process can be repeated all over again, either for a new for training a new model, or for retraining an existing model, because there is a concept called the data drift. The data changes, the behavior of the data changes, and the model that was trained using similar data in the past have to be trained again to understand the current state of data. Now, the process is preparing data and training the model and the evaluation. So in data preparation, you have handling missing data, handling outliers, handling imbalances, and scaling, feature engineering, selecting features. All these steps, we will be using a practical data points to train, to practically see how we do things. Now, today's session is more of an introductory session of everything that we will be covering practically in the subsequent weeks. And the model training involves choosing the right algorithm. You may be choosing a classification algorithm, which are the k-nearest neighbors, the naive Bayes, decision tree, random forest. So among the different algorithms, you choose one for the classification, depending upon the type of problem that you're dealing with. Or if you may be interested to create a regression model, and for regression, we have linear regression, logistic regression, support vector regression, and all kinds of different regression approaches and algorithms. And we may be interested in unsupervised machine learning, which is clustering. We may use K-means, K-means plus plus, or hierarchical clustering, or spectral clustering. And on another unsupervised model algorithms, we may be interested to dimensionality reduction, the PCA, principal component analysis, and the T-distributed stochastic neighbor embedding. Each of these, we will see at least one example from each of these algorithms. And during model training, we can choose algorithms depending upon the type of problem that we wanna solve. And then we evaluate the model. Just when evaluating the model, we could use different types of metrics. For classification, we could use accuracy, precision, recall, or for regression, we could use a root mean square error or mean absolute error. Or for clustering, we could use silhouette, score, and different types of metrics are there for each of the different models that we trained during the model training process to be evaluated depending upon the business problem that we are after to solve. And And another thing we have here is the Microsoft team data science process. So a couple of slides ago, this was our framework. This framework has been there, as I said earlier, for more than 2 decades. But Microsoft built its own framework for software development focused industries. So machine learning, the artificial intelligence data science, data mining can be done using this CRISP DM process. The CRISP DM process doesn't distinguish who does what, especially like just there are different disciplines in the software industry. Different people are have expertise in different areas. For example, for data understanding, you may not need a data science knowledge, right? For preparing data, you may not need a data science knowledge. But when it comes to model training, you would need to train to understand the different the characteristics of algorithm, or you may be required to write your own new algorithm, right? So that would require data science in machine learning and artificial intelligence knowledge, and even for evaluation. As a result of that, what Microsoft did is it's this segregated people as experts. For example, you have solution architects, project managers, data engineers, data scientists, application developers, and project leads. So after identifying these different disciplines, the process, as you can see here in this table, is I don't know how I can. I'm sorry. So at different stages of the development process, we have different requirements. If every individual has got a role in different phases, in business understanding or data acquisition and understanding or modeling or deployment, at different states, different people have got their own role, and just this is nothing but matching individuals in a task-based life cycle aligned with other processes. Now, the course resources, we have course resources, and then just I will explain what's going to happen in the next subsequent weeks. So let me know if there is any question here. I suggest instead of unmuting yourself, write down. I will watch for the next 10 minutes on the chat, and I will answer your questions. Okay. Thank you. Thanks so much, Cherry, for organizing the 2 questions for me right here. And what is your opinion on the use of machine learning in the stock market? Do you think it has been successful given the recent drop in the value of BTC and Luna? Can we conclude that the predictions made by machine learning were accurate? What does BTC mean? BTC, can you write down? I don't want to assume that I understood. I don't want to. Oh, Bitcoin. Okay. Bitcoin. Well, so I can answer this. Kibrab, the second question from Kibrab, when training the machine learning model, both training and testing accuracy is increasing, but there is a high gap between train and test accuracy. That is training accuracy is much higher than testing accuracy. How to report the final result. I mean, cutting point for the final result. Yes. Okay. I will explain these two. The first thing is what's my opinion on the use of machine learning in the stock market is currently being used. It doesn't need our opinion. Just the market is driven by using machine learning models, but models by themselves don't provide the full picture of what's happening because most of the time markets, especially the stock market, it is driven by people's action. uh, People maybe the model may have uh, just one of the input, one of the values that models watch in the stock market are the volume of trading. Trading means selling or buying stocks, right? That is one attribute, and that each of the attributes in the stock market have got their own corresponding weight, and the other weight for stock market is if there is any merger that's happening around a particular symbol or the particular company, or the other attributes or the other factor is what are people saying on especially just on the social media, what are people saying about the services and products that are being provided by that particular company, which is based on sentiment analysis of people. Or and not only that, but also what are the news, is there any news about this particular company? Is there any legal issues associated to this particular company in the market? So, and is there any change in the organizational structure? Has the CEO of the company changed it, right? Or one of the key players in the company has got a certain issue, right? Or said something bad. So everything contributes to the stock market, right? Of a particular. So all these are taken into account. More importantly, people's perception. The 2008 market crash was related to just people's perception, the psychological state contributed to that. So um, a market crash can happen with this or that, and the machine learning models don't understand the things that they are not trained with. If a new situation happens with an existing machine learning does not know about, then a wrong the model tells you a wrong answer to the right question. By the time you understand that just the model was wrong, it will be too late to fix issues. So that's part of the reason that I said, for example, here in the process, um, here in this process, once a model is deployed, there could be a change in data, there could be a change in the environment. So your model may be right for up until a certain point, but could be wrong. So when those kind of things happen, a machine learning model cannot properly predict the market. So that's a gap. So because of that, models have to be retrained again and again. And in relation to the testing, when training, I see people having, in relation to, so here, when training the model was training and testing, so this Kubra asks question, the second question here, I think, how can I bring this? Or you can see your chat window. I don't want to share. here. So, but when training the machine learning model, both training and testing accuracy. Yes, training and there is training and then testing accuracy. But the most important is the combined accuracy of the model. The combined. If the model performs so well during training and so weak during testing, don't use that model because the model is overfitting or just uh, learning more about the training data and just if it's not performing well on the testing, that's a good indication that it's not going to perform well on a new data because we will see in a practical scenario when we use actual data. So is in the algorithm how the learn pattern is represented. Learn pattern in algorithms are represented using different approach. So algorithms are trained using either we will see we can simply say using weight. How we interpret weight in algorithm, it depends on the type of algorithm that we use for to train a particular model. Weight, for example, in linear regression, weight could be interpreted as the code. Let me use a white word here. Okay. Let's see. Okay, so for example, for linear regression, the model could be beta naught plus beta 1 x. So the weight of a model means understanding what the intersection point and what the slope is. So our ultimate objective is understanding, calculating this. And this is how we will be determining the pattern and how we determine how the pattern is represented. Depending upon the different types of model, we would see weight represented in different ways. And okay. Okay. In multi-class classification problem, after we train our model, we plot a confusion matrix. From the confusion matrix, we calculate an accuracy of the model. But is this accuracy result training result or test result? That's a testing result, in short. I am confused, please say. It's usually like just the confusion matrix is based on a test data for classification. Can you share us the slides, please? Yes, I will. A question. One of the problems of model development using machine learning is model overfitting. What are the strategies to solve or minimize this problem? To do that, fine-tuning your model, and most of the time, including as much data as possible, and trying to use a cross-validation technique. And the other question is, as you mentioned at the very beginning of the discussion about the impact of machine learning, what are the positive and negative impacts of machine learning? Second, both data mining and machine learning use the same models. What is the difference between data mining and machine learning? Machine learning is just to start from the second question, machine learning is the superset. Machine learning is not only data mining. Data mining is somehow focused in a specific area to identify patterns. And data mining, in most cases, is unsupervised machine learning approach. But machine learning has the supervised approach where you train classification models and reinforcement learning, where you train models that can be used for robots. So that's the answer. The other question is, during dimensionality reduction, is there a risk of losing important features that are representative of the data? If there is, how can we handle that? Yes, there is a possibility of losing important feature, but the ultimate objective is not utilizing that data, but just to understand more about the data. The purpose of dimensionality reduction is not to maintain the important features, but to distinguish between among the features which are the important, between features which are the important features, not within a feature. So that should be realized. And can you share? Okay, I do. So if deep learning use artificial neural network, what uh, what does normal machine learning uses? So deep learning uses artificial neural network, and machine learning has got different approach. For example, logistic regression doesn't use so the linear model, the linear regression uses a mathematical representation, probabilistic calculations. Like some of the classification use naive Bayes probabilistic based approach. So that's how some of the machine learning models are utilized. But in deep learning, you represent learning just like humans learning ability based on neurons, which we will briefly touch at the end of this course. And how do you evaluate the performance of a machine learning model, and how what metrics are commonly used? We will discuss about this. We will discuss. We have different metrics. I mentioned some of them, but we have dedicated chapters, dedicated sections for this. And how do we choose a machine learning model, a machine learning algorithm to predict an outcome? And how do we know which algorithms are appropriate? Excellent, very good question. I will show you a cheat sheet of algorithms, what kind of algorithm that you should be using for what kind of problem. And I will show you there is a mapping between problem to algorithm mapping among the different types of algorithms that we can use in different machine learning frameworks. And the second question here is, when will we use principal component analysis for feature selection? We will see in an example. So when we use principal component analysis.